Hey guys, today I'll be showing you how to use the TI-89 calculator. So right now, I graphed a simple y equals x squared graph, and what I'll be showing you in this video is what all these options up here mean and how they help you analyze your graph. So starting off with F2 zoom, because F1 is just like open graph and save graph, we'll be starting off with F2 zoom. So first is zoom box. What this does is it lets you assign a new window to view your graph in, which can be useful if you want to go into more specifics with your graph or and have specific some specifications from which you view your graph. Zoom box can be really useful for that. Next is zoom in. Zoom in lets you choose a new center, and then it basically zooms in on that point. It's pretty intuitive. The same goes for zoom out. So we'll move straight to zoom decimal. And what zoom decimal does is it sets each of these ticks right here to increments of 1, which makes it more of like a standard XY coordinate plane. Instead of having the graph be based off of the pixels of the calculator, it will be just set to a standard 0.1 increment for each of your movements, which is useful. Number 5 is zoom square, and what zoom square does is it sets each of your ticks on the x-axis and the y-axis to equal lengths, because as you can see in the standard zoom function, the y values and the y ticks are a lot more bunched together than the x ticks, which can distort the graph a bit. So with the zoom square function, what you can do is basically let the ticks be the same distance apart, which allows you to graph squares and circles in correct proportions if you need to. The next function is the zoom standard function, which is the most common function because your calculator should automatically already be set to the zoom standard function, which is basically all you need most of the time. If you just want to look at a graph generally, zoom standard is usually enough because it shows you the graph and it's usually good enough. So next I'll be going on to zoom trig, which what this does is it sets each of your ticks right here on the x-axis to pi over 2, which can be useful for graphing trigonometric functions. As you can see, this is pi 0 for this tick. Next is zoom int and zoom data, which are both not really useful, so I'll be going straight to zoom fit. And what zoom fit does is it lets the calculator decide how to draw your graph best based off of the proportions of the graph and how big it is and how high up and down the y values are. So the basically what the calculator does is it automatically zooms in and out in order to make a best fit for the graph. So now we'll be going into the trace function, and what this does is it lets you trace along the graph with your cursor, which can be really good for analyzing either really small graphs or really big graphs, because it lets you see where the graph is going through your cursor and through your trace function. And something that's really useful that you can do in this trace function is assign an x value. For example, let's say 6, and it'll put it in here. And when you press enter, it will return the y value for that x value, which can be good for finding points on the graph. Next will be F4, which is regraph. There's not much to be said about this one. And next is F5, which is math. So the math function has a lot of useful tools to help you analyze your graph and get to know more about your graph. So starting off with the value function. And with the value function, you just need to enter an x value. For example, let's say 9, and it'll return the y value, which is useful. And then there's the 0 function, which I will use an example of sin x to show. So we graph sin x. Oops. Let's use standard zoom. And so with the 0 function, obviously it finds the 0 of your function. So what it will ask you is for a lower bound first and then an upper bound. And so what this means is it wants you to use a point directly to the left of your 0 and then a point directly to the right of your 0. So your calculator knows where to analyze on the graph. And so here, as you can see, the 0 is pi comma 0. The next math function will be minimum and maximum, which is the same concept. You select the lower bound and then an upper bound to the left and right of your minimum, and then it'll show you the minimum of the graph. And the same goes for your maximum. So the next function will be intersection, and I'll be showing you this with multiple graphs. So if we add on a y equals x squared, as you can see, if we want to find the intersection of these two graphs, we first select the first curve, which is this y equals x squared, and then the second curve, which is y equals sine x. And then we do the lower bound, which is to the left of the intersection, and the upper bound, which is to the right of the intersection. As you can see, the intersection is 0, 0. And the reason why we have to select the first and second curve is because if there's 3 graphs, for example, let's say we add on this graph, there are going to be multiple graphs, so the calculator needs to know which 2 graphs you're going to be finding the intersection of. So in the first example, the first and second graph, or like selecting which curve was the first curve and which curve was the second curve didn't really matter, but let's say we have 3 curves and we want to find the intersection of the line and y equals sine x. First we'd select the first curve, and then we'd have to specifically select the line. And then we can do the lower bound and upper bound to find the intersection. And as you can see, the calculator locates it at 7.99067 and 0.990672. Next, we'll be moving on to the 6th function, which is derivatives, which is obviously very useful because it lets you find the derivative of your graph at a certain point. So let's say we want to find it here at x equals 2.40506. We enter, and it pops out the derivative. And something you can do with this derivative function is you can actually select the x value down here where you want to find the derivative at. So let's say we want to find the derivative at x equals 3 of the y equals x squared function. Or of the y equals sine function, let's say. And it shows the derivative. And something else you can do as well is you can find the tangent line of your function if you go down and use the tangent function. And so what you do is you select the curve once again of the graph you want to find the tangent line of, and then you can once again input an x value, let's say -3, and then it'll both graph the tangent line and return the equation of the tangent line, which can be really useful in calculus especially. And so that's it for the functions up here that I'm going to be going over. But now I'll go over specifically how to save your functions. So when you go to Diamond F1, you're going to have this list of equations that you can put into graph, right? And these are automatically going to be saved functions for you to use if you want to in your home screen. So for example, here y1 was y equals sine x, right? So if I go home and I type y1 of, let's say, pi, right? It's going to automatically pop out 0 because it remembers the y1 function here. And that's just basically how you save functions, and it's really easy if you need to repeatedly use the same function over and over.